this one. So this is again all in Live SQL, and it is already published, so you can either watch me doing it or you can do it yourselves, but I created it today. And if you go to Live SQL, sorry, Blaine,
you can't see the URL. It's live SQL, so livesql.oracle.com to get you to this.
Right. Yeah, or you could just Google for Live SQL. I think we're the only one showing up there. You need to log in though. I am already logged in. Am I not? Sign in. Let's see what happens. And then you can, let's see if there is JSON.
You're not. I see a sign in link on the upper right.
Let's see what happens. So JSON object. Oh, there's actually quite a lot now. Error handling with JSON object types. JSON, that's not showing up. So I'm going on my scripts here. Maybe it has not been indexed yet, would be odd. But I created this JSON and object type mappers. And that's what we're gonna do today. And that's a script. And I run it, and then we go over it, what's actually happening. Then we go through it step by step, and I'll explain what's happening and why it's happening. And you can, I think you can always put questions in the chat, and Blaine can interrupt me. I think we do have sufficient time to go over it. So now I'm going on my session, and we just see it differently. So yeah, today we're gonna talk about object types, which I don't think is super popular these days with new development, but there might still be quite some applications out there which use object types. Blaine, do you know how many people work brand new with object types these days?
I guess it really depends on whether your language enforces types or just lets you type in whatever you'd like. I think lots of people still work with types, but I think it's more of a, the word means different things to different people nowadays.
Well, I mean, while doing this, this script here, I found out that one practical use case might actually be to enforce a schema. So you're using types, not necessarily to store the type instances, but rather to enforce a schema when you call a function or a procedure. Whereas if you just pass things around as JSON, it's schema flexible, and there's no means to really enforce that something conforms to a schema or not. So we start very simply here. We just create a type here, and it's an address, and it follows more or less a US street address format. And the first thing you realize if you invoke the constructor of this new type, so I'm creating an instance of that type here. I think in the Java world, this here would be called a class. And now this is if you invoke the constructor, you have an object, and the terminology is a little different in Oracle. It's type, and I think it's called type instance. But the first thing you know is if you want to create it, it works, but you can't really visualize it in Live SQL. So you see unsupported data type. I don't know if people are working on it, but right now we have to use a few workarounds, which I'm showing later, to make the contents visible. But the first thing we're going to do is we're going to feed it into our JSON object generation function. This is a function I demoed probably a couple of months ago, maybe even a year ago. So this is what we call a JSON generation function, because it generates a JSON, in this case an object, given a list of keys and values. And here we have a key called myKey, and now the value, instead of being a relational column, it's the object type instance. We're just creating it here with a constructor, and we see that we generate this object, and inside the object we have this new myKey, and its value is an object that got generated by using the SQL names from the object, basically using the names of the type definition, street, street number, as key names. And then we populate them with the corresponding values. And we also use data type information. So for example, the 500 is a number, so we don't put it in double quotes as a string, whereas all the rest has been converted to JSON strings. So the first thing you might realize here is that when I defined my type, I used lowercase or mixed case strings as my SQL names. But now the JSON that got generated, that uses all uppercase names. And the reason is that everything gets uppercase in Oracle unless you put it in double quotes. And I think it's quite common to not put things in double quotes, so I kept it in the most common way. But if you would put double quotes around zip, then that would remain lowercase. But if you would do a describe here, you would see that the street becomes an uppercase street. Okay, so we've created this key value pair with a value being an object, but it's even simpler. I think this is somewhat a artificial case because you have to define this new key, my key. Why do that if all we want is really an object of the a JSON object from the Oracle object? So that is the other syntax here, where we feed the object type directly into the JSON object without specifying a new key name here. So this is just JSON object. It's the instance, and we see that the same object has been created, but now it's an object without a new key, so this object value has not to be associated with a new key. So this is a different syntax, because normally the JSON object syntax has this key value list, key this, value this, and here you don't have a key. So quite straightforward. Now what happens if we have null values? So here in the constructor, I put in a SQL null, and it gets mapped to the JSON null value, which is sometimes desired. Sometimes you would want to omit such field, which is also possible if you just say absent or null. So here we do a JSON object, one of the fields is null, and we say there is an absent or null clause, so it's getting omitted. This absent or null is a global parameter or a global thing, so you couldn't say I want the zip to be omitted if it's null or absent or null, and I want the street to be a null value. So if you wanted to do that, what could you do? Question to the audience. If you wanted to generate an object where you couldn't use the global on null behavior, but instead you wanted to be very specific about which value has to be present or not. Any idea? Anyone still there?
On the chat, it says one method to visualize the attributes of object instances is to include a print method in the object type definition.
I have to read this myself. Where's the chat?
For you, it's going to be on the top of the screen. If you hover near the title bar, drop down, thing will drop down, and you'll be able to get to chat.
The more, yes. Yeah, you could do that. I haven't thought about this. My thought was you could always use the DOM API methods that I presented last time, so you could hand code your way in PL SQL out there. The moment you have like conditional behavior, if you generate things, if you have if then else, then just use the PL SQL control structures like loops or if then else statements. So we wanted to keep these things quite simple. So that is why this absent on null is global. The other one is the null on null. This is the default. So if you say null on null or nothing, then these values will be rendered as null. Okay, so this is, I think, quite straightforward. The returning clause also allows you to return the value as a CLOB. varchar 2 is limited to 32K. I wouldn't know any use case where you have objects exceeding that. Never seen that, but as I mentioned in the introduction, I'm absolutely not an expert on object types. I learned a lot today and yesterday when I set this up. So I don't know if objects can grow this large. They may be if you nest things, if you have an array of objects and so on, that at some point, if you have a list, you may want to have that to be returned as a CLOB. But one object exceeding 32K, I don't know, but it's possible. So you can say returning CLOB. Doesn't really change the output here. It's all looking the same. Okay, so let's create another type, which is called the person type. And the person has an address type in here. So we are nesting our type definition. In addition to the address, we do have a first name and last name and a date field. And now if we create the object of such two types, like our person type, I'm constructing the person type here, and the person type, or in the constructor, I use also the constructor of the address. So this is actually constructing two types and using one and the other. Then we see that the nested property of the object definition is replicated in our JSON. So we have a JSON object, and for our person, which has the first name and the date of birth, and the address itself is now a nested object. So I think this is very neat, very symmetric. If you nest your object types, you will get nested JSON back. One thing here with the birth, so I provided the birth in using a toDate and a string, which has some date format, which I think LifeSQL uses. Oracle provides typically a format clause to the date, and the NLS settings matter. We will always use ISO 8601 in our date here, so you should never see any different format for a date. If you use a timestamp, you will see a bit more information, but there is no NLS settings in JSON, or if you change your NLS settings, the JSON you generate should not change. So this is just to have the JSONs being self-describing. Otherwise, you would have to put like a date value and a format clause next to it, which I would think which would look quite odd. Good. So this is again an oddity, or not an oddity, but a property of using LifeSQL here. If you would run such query in SQL Plus or another client, you wouldn't see the JSON being pretty printed. So the fact that you can, does it actually work? Yeah, I can open these things here. This all rendering, that's all done by LifeSQL. If you would use SQL Plus, you would just get one long string back, and it would be hard to read it the way it's done here. So that is why you can put JSON serialize on top of it, and you put the pretty option on JSON serialize. Then you would even see this nicely rendered with indentation and new lines in SQL Plus. So here it makes no difference. Good. So that covered object types and the nesting of object type. There is one limitation here, which is that refs are not supported. So here in our type definition, we include one type in another type, but you could also use refs here, and that is not supported. One reason is that with refs, you can actually span graphs, and that would be hard to map that into a JSON tree. I wouldn't know how that could be done, and we avoid the problem by just saying if you have a ref, then you will see an error. So that covered the objects. What about collections? So I'm creating a V-array here. It's a V-array of number. It's a three-dimensional point. And I create an instance here with 3 coordinates. And I'm passing this into JSON array. And I see that instead of an object, I'm getting this now returned as a JSON array. Another way of using a collection would be to use a table of. I don't know the right term of it. I don't know if it's called a table of type or so, but this is basically a table of addresses. So if I have an arbitrary long list of addresses, I could create this as a table of address T. And if I put such a collection into the JSON array, then I would also see this as an array. In this case, it's an array of objects. So I'm creating my table type here, address table type, and I'm constructing it with 2 objects of address type. Give this to JSON array, and what I get back is a JSON array with 2 objects here. Now, this could be an example where returning a club or a blob might make sense. If you have an address type here which is quite long, then it's something I could see that 32K would not be sufficient. Yeah, I get this. But like for the nested object here, probably 32K is good. So this
is a question.
Yes.
What happens if you pass a V array to JSON object?
Oh, that's a good question. I think right now it's not raising proper errors. If you pass a V array to JSON object, I think it's returning it as an array. That's one of the bugs I filed today, which is that this should not be supported. Let me just see what the question myself that I'm not that good at. Yeah, VArray to JSON object should be an error. Niels, do you know what's happening? I think I tried it out today and I did not get an error. I got an array back and I found it confusing that JSON object would return you an array. So I asked the person who implements this to look into it and to potentially fix this by raising a meaningful error message. Good. So now I've covered the one direction that if you have an object type instance or multiple, how you can generate JSON from it. Now let's go the other way around, where you start with some JSON data and you want to instantiate an object from this data. And that is quite easy. We're relying on JSON value here. And in the returning clause, instead of saying returning varchar or returning date, we just say returning this new object type. So this is the value I'm passing in. I'm passing the entire person record. I have the path expression, which selects a value or a fragment. In this case, $.address would select me this portion of the data. And returning address type is calling a constructor to build me the type. So again, we see unsupported data type, not because this doesn't work, but because LifeSQL doesn't know how to render it. So we have to use the workaround I mentioned before. So I'm creating a table address type or address tab, and it only has one column, which is the address type here. Then I insert the data into this. So this is the same query. I'm just inserting into the table. And now I can do a select, and I extract some fields just to show that the values from the JSON have been used to insert or to build a type. So this is a level of indirection here, because I can show the type instance directly. I insert it, and then I extract the values and show the values. It's a bit of a hack. If someone more familiar with LifeSQL knows a better workaround, please let me know.
There's a follow-up from before. It says, at least if you specify a key, it should create an object key having an array value.
Oh yeah, absolutely, absolutely. This is the use case we started with, where you had this one here, where you say I have a JSON object, I give it a key, and the value happens to be an array. That is correct. That should definitely work. But the question is, if you have JSON object and instead of passing in an object type, you have an array type here, I believe this should raise an error. But it's currently being discussed. I'm discussing it with a person who's the primary developer on this, and we see where this goes. Okay, where have I been? I think we are at step 19, exactly. So now we do the same with a person table, and instead of extracting the address fragment, I select the entire document, so the entire object here, and return it as a person type. Again, I insert it into the table, and I'm extracting a handful of fields here. One is the first name, which is a top-level field of the person, and then I extract the address and the city, which are part of the nested address object. So you see that similarly to the creation, where we walk the object type hierarchy, or the nesting, and create the JSON. Here it's the opposite. We parse the JSON and we instantiate the objects also in a recursive manner. So this operation here created us the person type as well as the address type. Also quite straightforward. Now, there is one thing which is also, which should be working, but it's not working. It's, I think, a bug we fixed very late in the game, and it's not on LifeSQL yet. So I assume that the next patch that hopefully installs this. And this is that the mapping is typically done case insensitive. So right now what I'm showing here, the mapping is done case sensitive. So zip would have to be uppercase. If I would use underscore zip, it wouldn't work. But that is something, that was a bug that we fixed. And the reason is that in JSON, typically people don't want these uppercase letters. If you look at JSON examples, you will almost never find field names which are all uppercase. They're either lowercase or mixed case. Whereas in Oracle, the type definition, they're mostly not quoted and thus uppercase. So we said to satisfy, or to basically not force people to use uppercase JSON, we want to do a case-insensitive mapping. And if people want case-sensitive mapping, they can use this clause to specify that they want it. But that fix is not here in this, I think, 19 version of Oracle. But it should, I think, it should come. This is why I left it inside. So if an update is done, then this query will work and you don't get this missing keyword error because it doesn't know the case-sensitive mapping clause here. I also think this is part of the standard. So it's really, we basically put out a version where this was missing. Good. Yeah, this didn't work. So this is why we can't select anything, nothing to be deleted. So let's look into something that could also happen quite often, which is also part or something that happens if you use JSON, which is you may have missing fields or you may have extra fields. This is just because of the nature of JSON not having a strict schema. So here we're inserting into our person tab and we have the first name field, which looks fine. Then we have an age field, which we don't have in our type, and place lottery, it's also not there. We don't see any error here, it's getting inserted, but if we do a select, we see that only the first name could be used. So we found a match for first name and we didn't find a match for all the other fields, so they become null. That is the default, which is fault tolerant, but that might not be what you want.
There's a question there.
Yes.
Is it really written with a minus and not an underscore?
Yeah, it's correct. It's a minus. So that query works on my dev box, which has a newer release. Yeah. That's correct. I mean, I would be surprised if it worked with another case. I haven't tried it out, but I don't think this. No, it's not the issue, because even here I had intended in this demo to show the case insensitive matching by using different writing of zip, but then I saw that it failed on Live SQL, so I had to always write zip in uppercase. Like in my original demo, this was lowercase, and it would still work because of case insensitive mapping. But once I moved once I uploaded the script to Live SQL, that piece stopped working. So I think this thing is not there yet.
Yeah. So I mean, this is just my observation, but you do have an OR error right there in that statement.
Yeah, that's a parse error, right? That's probably the parser that raises this.
Yeah.
Yeah. Good. Okay. Okay, so now we have this optional error on mismatch clause, which means if the mapping cannot be done 100%, if there is a mismatch, just raise an error. So here we see missing data for object type conversion. I think it would help if we would also know maybe a list of things that didn't match. Let me just take this down as a note. See, it's like once you use the stuff you build, you find a lot of things that could be improved. This is one of them. So error on mismatch basically makes sure that the JSON and the object type do match. So question for the audience, why is there no such mismatch in the other direction from the object type to a JSON? Well, nobody wants to reply to my questions. I think I stopped this game. It's basically
the JSON is generated based on the object attributes.
Correct. And there is no schema, so there is no possibility of ever being a mismatch. It just uses all the member names or attribute names in the type definition and generates names from that. It's the other direction that's problematic, where you have a schema-less JSON as input and a strong schema on the type.
And
so this
next one said because JSON does not know what keys to expect.
Correct. Yeah, absolutely. So now we see there is this error, but we can further specify what kind of error we want to be raised as an error. So there's basically two things. One is you don't have enough data. There is a field that is missing, or you have too much data. So you can't, so in the one case, you cannot instantiate all your members with values or your attribute with values. And in the other case, you have too many values and you don't know what to do with it. So if you say extra data, then this will actually go through because there is no extra data. First name can be matched, but everything else will be instantiated with null, but you want to make sure there is no additional data. And the inverse case, if you say missing data. So this is an example where you have a JSON, there is an extra field here that would be raised as an error if you just say error on mismatch, but if you limit this to missing data, then the insert actually goes through and this extra field is getting ignored. So I think this really depends now on your use case, which of these two options you want to use. And again, they are global. So you can't say street has to be there or address cannot have any additional fields. It's again, if you have this kind of logic or business logic use cases, you would have to code that in PLC codes. Again, the simplicity that we targeted here, so it's a global handler. Then, okay, what was this? Extra data. Yeah, so if you specify error on mismatch extra data, then this extra data field here will now be detected, doesn't know what to do with it, and it raises the error. Good. So type conversion is done implicitly if possible. So far our street number was always a number. So this was a JSON number, and the JSON number was mapped to an Oracle number. So the data domain was the same. But here we have an example where the data domain is different. We have a 500 as a string, but we still map this to the number field in the type so that this raises no error. But if we turn this string into a string that cannot be converted, I'm adding an X here, then you actually see that this is a type error mismatch. If you don't specify error on mismatch here, this one is actually getting ignored. This was also something I had to think a little bit about, whether this is not a bit too fault tolerant. But the default here would be street number is present. So there is not too much data, not too little data, but the type conversion is not possible. If you don't specify error on mismatch, it's just silently falling under the desk, and you might wonder where the value has gone. So if you worry about these cases, it might be helpful to always write error on mismatch. So it's again something I need to think a little bit about, whether the level of fault tolerance is really the best idea here. Good. So there's one special case. What would be the world without special cases? And that is SDO geometry. So I don't know how many of you are familiar with this, but this is a spatial data type. So you can specify not only points and lines, but also regions and circles. Not an expert on this, but it's used, for example, to do maps and calculate distances, paths, etc. Also has its own indexes. I think it's called the R index, which relies on bounding boxes. So it's a quite powerful data type for spatial operations. And the nice feature is that it conceptually maps, I would say, one-to-one to what's called GeoJSON. So there is I'm not sure if it's a who came up with it, how official it is, but there is a GeoJSON, let's call it standard, which specifies how to render spatial information as JSON. So you don't have to come up with your own format. If you have spatial information, it's that you have these geometry values, you have a type. In this case, it's a point, and it looks to be a two-dimensional point because it has an array of only 2 coordinates. And there is a conceptual one-to-one mapping between SDO geometry and GeoJSON, but it uses different names for the values and also a slightly different schema. So what I'm doing here, I create a table called Spatial Objects. It has a column obj, which is of the spatial data type SDO geometry. And I'm inserting into this thing, I use the JSON value. I give it, this is an example I pulled from the GeoJSON website, and I extract the $.geometry object. So it's actually this object here. All the rest is additional metadata, I would guess. And I say returning SDO geometry. And what it does, it's not trying to map things based on coordinates and type and so on. Instead, it populates the Oracle SDO geometry fields, which you can see are called quite different, and we get this information back. So the point X and point Y, they map one-to-one to the GeoJSON, but you have this G type, which I think the 2001 stands for point, and the SRID, if I'm not mistaken, is the used coordinate system, whether it's, well, I don't know, I'm not an expert on this, but that is the equivalent of this here. So why do I show this? Yeah, I show this if you ever have this GeoJSON in your data, it's very easy to make use of Oracle by just turning it into an SDO geometry. So it basically means at this point you have your spatial information in the Oracle database. You could then create the R index and easily do distances or whether a point is close to something else, these kind of operations using the Oracle database. Interestingly, the inverse operation, if you have such instance here, so this is actually a circle. So the 2003 makes it a circle, and then these are all kind of values I don't understand. But if you use JSON object, you actually see it turns it not into GeoJSON, but into, it uses the generic mapper and creates a JSON instance using the key names from the type definition. So we see SDO underscore G type, etc. Not something that a GeoJSON application would understand. Again, something I have to go back to the developer and see if this is what's wanted or not. But there is a workaround, which is just the SDO util packages. So they have from JSON and to JSON, and you can do use the same SDO geometry object here, and you say to JSON, and it converts this into this nice GeoJSON thing here. Surprisingly, the points look different. Polygon, boundary, circle. I can't read this, but my guess is that this is correct GeoJSON. Good.
So there's let me just throw this in. There's a feature in SQL Developer if you run spatial queries. I haven't tried the GeoJSON, but if you run spatial queries, you can actually right-click on the results in the bottom window where your query results come up and say display the image, and it will pop up this little window that displays the image that you just generated with your query. So just as an added tool, if anybody wants to check that out, SQL Developer's free.
Yeah.
Check that out.
Yeah, I've never done that. Not an expert on SDO. I only met the guy who invented the R index a long time ago. Was a nice person. Okay, so one use case here, if you remember, was it last time? Yeah, I think it was last time we spoke about PL SQL and JSON, and I had a little example where we used the PL SQL types object T and array T, and we would parse it and use it to modify a JSON. So I came up with a similar example here based on object types. So assume I have a person and the person has the address with street name and house number, and I just want to anonymize it. I want to remove the exact location and just keep this zip and the city name. So I wrote this function anonymize. It takes a person type, and all I do is I set the street to unknown and the street number to 0, and then I return it. Wasn't able to actually get the same thing returned. It was always complaining about in-out, so I had to create this P2 and copy my persons. Anyway, so this looks long here, this example here, but it actually only looks long because I inline the JSON data, which is my person with a street address, Oracle Parkway 500. So what I do is I use JSON value to first build the object type person T. I feed this into the anonymize function, which returns me the object type without the street and street number information, and then I use JSON object to turn it into JSON again. This is the result. We see that the street is unknown and the street number is 0. So this would look much smaller if you would just remove all this inlined JSON. I think this is just one use case where at this point, because you use object types, you couldn't really pass in the address directly or something else. So that's a way to make your JSON-based code more schema-based. If you would pass in the JSON directly, for now this would have to be a varchar value, and then it would not prevent you from passing in any other JSON, which would not be a person. Since we are talking about PL SQL, there are some limitations which are still around, and one is that the JSON object built-in function does not support object types as of today. So it's built in. So you can have the key colon value or key value semantics here, but the moment you pass in an object type, it would actually raise an error here. So that's attributed to the fact that a lot of the work we do for SQL has to be replicated for PL SQL. They don't rely on the same parser and on the same execution engine, so it's a bit of double work here, and PL SQL is lagging a bit. So this is just a temporary thing. I think we will get to it in some future release, but it still would need to be worked on. So for now, how could you do it? Well, there is this execute immediate workaround where you stash the SQL query inside, and that actually now uses the SQL code path to be executed inside PL SQL. So I use this into clause to populate my variable, and using P1 to get the person type into JSON object. And you see that if I call this with an object type instance, then I get this value being returned. The other things that are also not working yet, I'm just very open for now, is that record types. It appears that there is a PL SQL limitation that the workaround we used here in the passing the using P1 where we put in the object type. So this works here in the workaround for an object type, but I didn't get to work it using record types and also not associative array. So I think it would be nice to, if you use an associative array, if you could easily turn this into a JSON object. I think it's a natural fit.
There's a question. It says, couldn't you just do a select without the execute immediate?
Haven't tried it. Probably you can do that. Yeah. I'll try it, and then I may correct this, but it wouldn't work either in these later cases here. This appears to be a limitation of PL SQL, so our JSON object code path doesn't even get hit here. Good. So yeah, let me know what you think. How many of you are using object types? And what is interesting? What do you think you can use, or where do you think we should be focusing on extending this? This was I basically concluded with these two gotchas. I concluded the presentation here. I don't have any more examples for you, but Yeah, I would be interested what you think. Are there people in the chat who use object types in PL SQL, and is this something you think is useful? So let's wait a bit. Maybe people are typing now. So the question is, I repeat it, is any one of you using object types either in new developments or in legacy systems? And is the ability to use JSON with object types something that you think is useful and we should be focusing on closing the functionality gaps soon? Or would you rather say, nah, that is not a typical combination. It's fine if those limitations take a little more time. Okay. We got one feedback, which is encouraging to think that this is a good route.
So I don't know if you saw the response. It says the yes means I'm using object types in PL SQL, and the conversion to JSON is really interesting, although I haven't used it now.
So Niels, do you think the current level of support is sufficient, or should we also look into more into supporting these index by associative arrays, record types? I mean, this looks to me that it requires a little work, but it looks like the mapping is natural, and I would tend to say we should close this gap, although it's something that probably has to be done by the PL SQL team, not by us. Okay, and I almost always include a print method. Oh, I see. So you are printing, if I understand this correctly, Niels, you are printing the state of an object, and you could imagine printing it as JSON instead of listing all the attribute values. Is that correct?
Can you hear me?
Yes.
I can hear you.
I think it's an easier method. An advancement for index by arrays would be good.
It's the bottom example here. Index.
Yes.
Okay.
For records, for me, it's not necessary because I then normally use object types in such cases.
I see. Okay.
And the print method, I use it either to generate a string, like we have done here for JSON data, or to write it for debug purposes into DBMS output or the protocol object type or something else.
Yes, I see. Okay. Besides these two gaps that I pointed out here, do you see anything else where we should be, something we missed?
Not at the moment.
Okay, good, yeah. Yeah, I think maybe this is something we're gonna revisit, I don't know, in half a year or in a year, I don't know. I mean, not only depends when we code it, but also when it ships. But I hope that in some future version, I can show that this is working, and then we just do a little detour in another AskTOM, and I hopefully can show that it's working. I found this index by thing. I think this really maps nicely to a JSON object.
There's a couple more comments on there.
Yeah.
First one is the PL SQL types will probably only work with native PL SQL implementation of JSON. Otherwise, they generally do not work in the SQL layer.
So the PL will probably. I'm not sure I understand. Like the PL/SQL types will probably only work in native PL/SQL implementation of JSON. Otherwise, they generally do not work in SQL layer. Yes, those types at the bottom, that's correct. The VArray and the record don't work in SQL, right? That's only if you use PL/SQL. Yes, that's correct.
The next one says, I usually use object types in PL/SQL 2. I think with JSON we can integrate with other data motors.
Yes, yeah.
And then the final one says, not using object types in our company. However, I would describe our development team as small and not very mature when it comes to PL/SQL.
Got it, yeah. So the question that I don't really know how to answer is, I think there is a growing need for some sort of JSON validation, especially if documents get larger and evolution can happen. So let's say you receive a JSON from a third party, and you just want to make sure that it conforms to the schema that you've seen and that your partner doesn't add or remove fields and your application breaks. So I think at some point we need to look into schema validation. The question is just, is object types a means to do that people write such schema as object type, or wouldn't it be better to say I have JSON schema support in the database where I could not only say this is a number, but I could also specify, I don't know, that it has to be in a certain range or a positive number, something like this. So how do you see the need for JSON validations in general? And I think this is also my last question today. I'm asking a lot of questions today, I realize. So,
so the comment there, I don't think I read this one already. For example, the PL/SQL native JSON object can probably do the same with the PL/SQL record as the SQL level JSON object does with an object SQL type.
Right, yeah. Yeah, that's correct. Yeah, the record is just, it's the same, or you can express the same, it's just a different data type. And I don't know if people who work a lot with records would prefer that they are supported natively, which probably some people would also argue for. Yeah, the schema validation thing is something in the back of my mind where I have to think about, but so far I have not really come to a final conclusion to what extent. There was XML schema, which I think was by far way too complex, way too powerful, to an extent where it would just confuse normal people, including me. And I don't think we want to go the same route with the JSON schema, so we have to continue the keep it simple philosophy, but still support some means of validation. And as I've shown it here in this function, it may be a means to enforce a schema. Where do I have it? Here, the anonymous. But I'm not sure how much this is really a good way to do it, or I just made it up. Okay, so if there are any more questions, otherwise we're 10 minutes shorter than usually, which is not bad, I guess. What will happen if you have an object type, ID number, data varchar 4000? Yes. And JSON.
I mean, if you use JSON value.
Yes.
Would the JSON of the data?
No, this would be a mismatch because the data is an object, whereas the mapper would expect it to be a scalar value. So I think this would be a type error. Because you can easily map the ID. You have a number in the JSON number, which you map to an Oracle number. But then your data, if you want to populate your data field, you're expecting a string, but the value in JSON of the data is not a string, it's an object. So it would not turn the object into a string. It instead would treat this as a type error. And there would be no syntax to specify any other behavior. So if you have such a use case, let's say you wanted to concatenate the hello world or whatever, you would have to write this in PL SQL, which you can also do because you could parse the entire string as a JSON object T. That's what we covered the last time. And then you could hand code that kind of logic yourself. Okay, so there's another statement from Judith. The idea of using a JSON schema could be nice, but without complicating the simplicity of JSON. Yeah, totally agree with that. Maybe using some functions like JSON schema to generate a schema and JSON validate to validate a given JSON value against the schema. Yeah, that's, I think, one very simple thing, but I think you would also have to be able to specify like this field has to be not null. And some more properties as well. So for example, that shoe size is in a given range, for example. Like not only say shoe size is a number, but shoe size is from, I don't know, 5 to 13 or so. Yeah, that's something that's bugging me sometimes. We'll come up with something. Cool. Perhaps time for a real JSON type data type. That's not the first time I heard that, but unfortunately I cannot say anything, but it's always good to be at open world.